is our wind tunnel apparatus. In this apparatus we can find the drag and lift coefficient of the bluff bodies and aerofoil set bodies. Here one cylindrical bluff bodies are kept, in which a fog machine are kept in at the inlet section. If we start, then flow visualization can be seen through the cylinder. And this is your pitot tube, which is connected with a vertical probe, and this is the adjustment. We can touch it the bottom plate. If we touch the bottom plate, then velocity profile can be found over this flat plate. If we keep on moving upward, and at some distance its velocity will be constant. That is known as boundary layer thickness. So this pitot tube has two ends. One is stagnation end, other one is static end, and both this end is connected with inclined U-tube manometer. This is the inclined U-tube manometer having graduations, and the velocity is controlled with the help of this variable frequency drive. As we know that the frequency of India is 50 Hz. Here initially I have set it at 0.15 Hz, and here is the fog machine. It is the starter of the fog machine. As we press, fog will go through this inlet section, and this is the wire mesh of the wind tunnel, and after that this is the honeycomb structure, and these are the all throughout the wind tunnel linings. And at the exit, one ID fan, 3-phase ID fan, 7.5 HP motor are placed to suck the fluid from the inlet. So each component have different namings. This portion is known as effuser, and its contraction ratio is 9:1. And these are the settling chambers, and this section is known as test section, in which we insert the bodies. This is the bluff body, cylindrical bluff bodies. If we want to find the drag and lift of aerofoil, then we put it inside, and we can change the angle orientation manually from here. This is the compass protector. You can change the angle variation from here. And this portion is diffuser, and these are the ID fan with the exit. So if we apply Bernoulli's equation at these 2 points, one is stagnation point and static point, means delta P by W of water. W is the specific weight rho g, and it is equivalent to B square by 2g. And after putting all the formulas, we get this formula to get the velocity of air, root under 2g delta H of water sin beta density of water by air, and finally this is 65.05 root under delta H of water. So delta H of water is basically here the difference in the manometer, inclined U-tube manometer having inclination angle 15 degree. Now I am going to show you that inclination. We are moving the, yes, one more thing. If we are running this wind tunnel at 50 Hz, yes, here is the maximum rated speed. We have run at 50 Hz. Delta H of water comes 27.5 centimeter, and the maximum velocity is 34.11 meter per second. Let's come how this wind tunnel works. We are increasing the frequency with the help of variable frequency drive machine. This is the VFD in short. We are putting the frequency up to 33 Hz. Now it's being started. bodies, and this is the pitot tube. Pitot tube is connected with both this one stagnation and static point, and we are getting this difference. Here is H1, this one is your H1, and here it is H2. So this delta H of water we are putting in the formula derived from Bernoulli's equation. And this is the ID fan section. Visualization, we putting the frequency at minimum. We can get to a higher frequency also, which requires high speed camera. Now we are decreasing the frequency. Again we will start the fog machine. This is the fog machine. Wait, sir. Yes, okay. So in this way we can see the flow visualization of the fast cylinder. We can change the body from this section, this test section. Aerofoil bodies can also be put here. This is the Bluff bodies, one of the Bluff bodies. Thank you.